this is the date when the European elections happened in Germany, actually. So that's 5 years ago. And well, I want to take you now on a little time travel, actually. I'm a journalist and data scientist, and I just want to give you a quick insight into my journalistic work back then. I was working on a project around the European elections, and one of my tasks was actually to summarize the positions of the 6 biggest political parties in Germany. And so, yeah, it was a lot of work. So I had a lot of those here, actually, with a lot of documents that were all connected to the European elections. And yeah, as you can imagine, yeah, part of it is, of course, search for the trustworthy sources, really read and understand the content with my team, and then sort through the overflow of information that we faced, and really focus on the specific topics that were relevant for our media format. And so when you look at it, when a voter takes an informed decision, then he probably has to go through a similar process. And that probably looks like that. Read all party manifestos and watch some debates, or just pick the party that you always voted for. And so wouldn't it be, so just look at this date now and make another guess. Yes, the European elections are just around the corner. And yeah, in the end, wouldn't it be super nice when we could just avoid all these problems that I just showed you 5 years ago? Voters were Googling manifestos, and now can we just not have it in a more summarized way, that we just can compare all the different parties' positions, and that a voter can really choose the topic that interests him and see what the party thinks about that, and not the media is really choosing the topic? I guess you all want this, and good news, we have it. It's Electify.eu. So this is the application that we developed. It's AI-driven, and you will actually have the possibility, or this is our goal, to make an informed decision for the European elections in 2024. So now well, maybe you could, there is also, what I want to talk about is really this question that you have on your mind when you now can ask a large language model, why do we do this all? And I will tell you that there are some problems with large language models when you ask them now which party to vote. And I will also tell you how we could actually overcome and solve some of these problems by using Retrieval-Augmented Generation. Chris will actually tell you then more about the technical details of our application, and he will also tell you what our application has to do with a kangaroo. So wait for that. And Joshua will actually walk you through our Electify application and show you the different features. So let's go here. So why is it not enough just asking a large language model before the elections? There are several problems. So the user can't specify the sources. Also, what we want is we really want to compare the different parties and get a summary. What are the positions of the parties? So this is also not possible. No multiple or systematic queries in the end. And there is actually, with a large language model, the problem that you don't have the access to the relevant data. In our case, for example, the debates in the European Parliament. We tested it several times. They do not appear in the responses. And so the training data is also outdated. We used GPT 3.5 Turbo that is stuck in 22, so really a bit useless, to be honest. And then the responses can also contain hallucinations, and we really don't know which sources are actually used in the end. So RAG to the rescue. RAG means Retrieval Augmented Generation. So how does this work? So we have a user that is, for example, asking, okay, what are the positions of the different parties about migration? And then now comes the crucial part here, actually. that we really managed to really curate a database with the relevant data that we chose. So the European debates and the party manifestos. And here actually will happen now the retrieval in the most relevant document snippets. And this is then actually used and the prompt will be augmented. And through this, the large language model can actually generate a response that is really based on the data that we chose and thought is the most relevant. And the answer can be more concise, more precise, and we can also trace the sources. So I want to hand over to Chris.
Thank you. All right, so the first step is, of course, the database. We have to download all the data. And thankfully, the European Parliament has an API and the party manifestos we can get from their respective websites. And then we have this very large pile of text data, which you have to slice into smaller chunks so that it becomes a searchable database. And this we do if you take such a short text as an example. Just go vote on the 9th of June, which you should definitely do, by the way. This could, for example, be sliced into two chunks, the red one and the yellow one. And if we allow for a small overlap, then in this case, the orange shaded text would actually correspond to both the first and the second chunk. And this is in order to not lose any context in between the different chunks. I also want to mention that, of course, in reality, our chunk sizes and overlaps are much larger than this. They are 1,200 characters. And this is because, of course, political text contains a lot of nuances and context is very important. Okay, next point is actually this natural text has to somehow be transformed into numerical features. And for this, we use OpenAI's text embedding 3 large model, which basically transforms any text into a feature vector, which ideally preserves the semantic meaning of the text. Okay, and finally, we store all this in a vector database, Chroma vector database, which also contains a lot of metadata like the party, of course, the speaker, the date of the speech, etc. All right, so now we have this database ready. Now comes the crucial part that Anna, of course, mentioned, is the retrieval. We have to find the right parts of this database which are relevant to the question. So we start with the question again. And first, we create again using the same model an embedding vector of this question. And then we go to our database and we search for slices which have a similar embedding vector. And first of all, we have a very simple search which simply uses cosine similarity and retrieves 10 slices per party. And then we go one step further and do this a bit more carefully. And this step is called maximal marginal relevance. And I won't go into much detail here, but basically what it does, it re-ranks these 10 slices and basically it avoids redundancy in the slices. So if 2 slices have kind of the same information context, then only one of them will be used. And with this, we boil everything down to 6 slices per party. So I should mention that these numbers, 10 and 6, are of course very important parameters. And we tuned them using hyperparameter tuning, which I will talk about later on. Okay, finally, we have these context slices. We kind of concatenate them together to get a very, very long string, which now contains a lot of information about this topic and build this context. And now finally we come to the fun part, the generation. We pass this very long prompt to a large language model. In this case, we used OpenAI GPT 3.5 Turbo simply because it gave by far the best performance of all the similarly price tiered models that we tried. And in the beginning, it's very quick actually build such a system, and you get kind of reasonable responses very quickly. But if you dig around and you try some prompts which might be maybe not so standard, you very quickly find cases where it doesn't work. And here I just want to present you one such edge case, which was actually really helpful to us to optimize our system. And it became known to us as the kangaroo problem. So you might think that kangaroos are not very crucial to European politics. And you're right. And that's exactly the point. Because when we asked this kangaroo question to our early stage model, we got this response. So a very long text, and it talks about the controlled release of cannabis, the European climate targets, and genetic engineering. So 3 completely different topics, which of course have nothing to do with a kangaroo. All right, so it became very obvious that the prompt is really important in this whole endeavor, because that's where you really dictate the behavior of the model. The instructions are very important. In this particular case, the kangaroo problem, of course, stands for a kind of a bigger issue, which is what to do if the context is not relevant to the question, right? So you really have to bake this into the instructions. And we went over many rounds of different iterations of the instructions to get this behavior right. Another thing that we looked at was metadata. And in particular, we actually chose to not include the party names as metadata in the prompt, because then the language model would maybe use information that it has learned during the training process about this particular party. And this is, of course, information which might be outdated and which we cannot control as well. And finally, one thing that is a bit peculiar is the order of instructions also makes a difference. The language models tend to give more focus to instructions which come in the beginning and the end of the prompt. So this is something you also have to keep in mind. These edge cases, they are really good actually to tweak the model. We managed to get rid of the kangaroo, but they only get you so far, right? So at some point, you just look at 2 responses from your model, you change some parameter, and you cannot really say what is better. So we needed a quantitative way to evaluate this. And here, I will now talk about how we tuned some hyperparameters of our model. And first of all, what we could use was one very nice property of these RAG systems, which is that the retrieval and the generation part can somehow be optimized kind of independently. So you can optimize the retrieval part without really disturbing the generation. And because it's very difficult actually to get like hard metrics, because you don't usually have a ground truth like in image classification in these types of problems, we use LLM generated metrics. Basically, you ask another LLM to judge the performance of your RAG system. And there are metrics like context relevancy, which, for example, tell you what fraction of the retrieved context is really relevant to the question. On the generation side, there is faithfulness, which measures hallucinations. And there are other metrics which are influenced by both retrieval and generation. And I don't want to go over all of this, but just to give you a flavor of how this looks like, here I show the context relevancy for different embedding models. And you can see that OpenAI embedding has actually by far the best performance here by quite a large margin. The 2 runner-ups, Gina AI and Mistral AI, are also GPT-based embedding models. And then we tried another model which is very specialized. It's a BERT model fine-tuned on political text. A lot of it is German. So we thought it should perform very well, but somehow still didn't reach the other ones. And the same goes for E5 base, which is a sentence transformer very often used in RAG systems. But we believe mostly due to the language, it was also outperformed by the other ones. Yeah, and this process we repeated for other hyperparameters, of course, most prominently the large language model itself, the number of retrieved slices. You can change the chunk size and the overlap, the instructions, of course, and the prompt and so on. And after all this, I think we are quite happy with the results. So we decided to deploy this. And now I hand over to Joshua for the demo.
Yes, so we hope that by now you're already a little bit curious what the results of this system look like. So we're proud to share a little app that we built around the system. It's built with Streamlit, and we deployed it on Google Cloud Run. And it's over here. I hope you can see it all right. I might zoom in a little bit. Yeah, that would be good when I type. So first of all, you can, of course, switch to English over here. And then really ask about any question that you care about in order to make your voting decision, right? Or just enter a keyword. Something that might be interesting to a lot of us is how should artificial intelligence be regulated? So let's type that in. All right. And then we can just also, ask a question. At this point, we are creating the RAG engine for all the 6 largest parties that we mentioned before. And the LLM, in this case, GPT 3.5, it generates some nice concise summaries for all of these parties. So we can see the parties in this case are displayed in random order, that some parties want a bit more strict regulation. For example, this party supports making the EU a hotspot for artificial intelligence. Other parties take a bit more cautionary approach, clear regulations, strict precautionary principles, and so on. We really want to encourage people as well to not only rely on this, because we know, of course, it still has some limitations. We want to encourage people to also click those links over here, which lead directly into the election program, into the party manifesto. And also, if everything works correctly, directly on the correct page where you find the relevant information. Now it zooms in. So this, if you don't know German, is the correct translation, or it's the translation of artificial intelligence. So now there you could read more on about that topic for that specific party. If you want to dive even deeper into how this answer came about, you can dive into all of the retrieved sources. So down there you can see for any given party the retrieved snippets from the manifestos, as well as from the debates, if you're interested. If you scroll even further down, you can see a little feedback tool, which already came to use because we had a little testing with friends and family, which actually quite informed some iterations that we did with this app, and some tweaks we did to the prompts and the overall experience. So you can just say, I don't know, maybe not so good, I miss the kangaroo. And then submit it. And this will submit not only the feedback, but also the prompt and the response, and that helped us really like narrow down some issues and debug. That's it. There's one more thing, a nice little feature that you might have spotted in the beginning already. We can actually tick this checkbox, and then the party names are not there anymore. So should actually do this first, of course, and then you will just see the summaries and not the party names. So we want to fight confirmation bias, of course, and this way you can just read what the party says and then reveal the party and see, okay, that's those. Okay, so that's the app. Yeah, we know there's probably still things to improve, but we're quite happy with it so far. We're really welcoming your feedback as well. And it was really important for us to deploy this and spread it a bit around, see how we can improve this. So we invite you to try this out yourself, submit some prompts, see how it goes, share your feedback, please. And if you feel like it's useful, let us know, spread the word. We have a few items on our backlog already. You might come up with some other ones. The most obvious one is we only have the 6 largest German parties right now. So yeah, we should definitely include smaller parties as well, maybe at some point, because there's a few more. And there's also this trade-off that we might want to revisit between rejecting a response and giving an inaccurate response. Right now, we tend to just reject a response when the model is not entirely confident. So yeah, so we just say in that case, no accurate answer could be found, which is sort of okay, but maybe you want something else. There's also a problem, especially in the debates data, where people just say the opposite of what they mean, and the LLM can't really interpret that really easily. So there's sarcasm, and we might find more like tweaks to deal better with that. We're also considering adding a self-reflective step to our RAG, because that's really just good practice. Really, a lot of people recommend this. We didn't get to it because of time, but that would effectively mean that there'd be another LLM query in the middle, sort of questioning the output, looking if it's right, and if it's not, maybe do some adjustments, querying again, and so on. So yeah, that's what's on our radar so far. Again, we really encourage you to try it out, give us some feedback. Thanks for your attention. Also, thanks to DSR for an intense training program.